Good morning students. Today in our class we are going to start with the new topic cuboid. Okay, already we have started with the chapter mensuration, unit 5 mensuration. Today we are going to start with the new chapter of surface area of cuboid. In this we are going to see the new topic surface area of cuboid. Okay, so before going to the area concept, first we will know what is a cuboid. Okay, cuboid, see the definition here. A cuboid is a solid with 6 faces. Each face is rectangular in shape and all the angles are right angles. The opposite faces are identical. Okay, we know about the rectangle, isn't it? We know about the rectangle. In rectangle we have opposite sides are equal. The longer side is called as the length and the other side is called as the breadth or width. Okay, here that is the relation between the rectangle and the cuboid. Okay, because the cuboid is a solid but each face of the cuboid is in the shape of rectangle. Okay, for example, see here. Actually in our day-to-day life we come across the shape of cuboid in our home, isn't it? In our pencil box, books, our fish tank. If you see many shapes around us in the form of cuboid. Okay, so by seeing this, see here I have an example of cuboid as a first aid box. Here 6 faces. How many faces are there in the cuboid? 6 faces. Count it. How many faces are here? 1, 2, 3, 4, 5 and 6. Yes, it has 6 faces. And each face is in the shape of rectangle. See, all the faces are in the shape of rectangle. Okay, so in the rectangle we have length and breadth. In the cuboid we have a height. Okay, along with the length and breadth we have the height of the container. Okay, see here I am having a container, here it is a height as angle. Every angle is right angle. We know that in rectangle itself all right angles are right angle. In cuboid also each vertex angle is right angle. The opposite faces are identical. Opposite faces are this. See here we are having one face and these two faces are identical. Identical means same, equal in measure. These two faces are identical. Likewise we are having 3 pairs of identical faces. See here 1, 2. This 2 1 and here 1 this. And these two faces are identical. Okay, so this is the cuboid example. See again once, a cuboid is a solid with 6 faces. Each face is rectangular in shape and all the angles are right angle. The opposite faces are identical. Okay, while diagrammically we will represent the cuboid like this. Okay, yes. Now in this section we are going to learn about the surface area of cuboid as well as the volume of the cuboid. Okay, for the cuboid we are having the area. How to find the area? We are going to find the total surface area, lateral surface area, length of the diagonal and volume. We are going to see about this. Okay, first total surface area. Okay, in total surface area, first in the cuboid we are having 6 faces. Okay, opposite faces are identical. So if you saw the example of the cuboid, see here we are having the first face. Take the base and top. Take the base and top. Okay, the base and top includes the breadth and length. Breadth and length. See here, if you take this example, this is your length, this is your breadth, and this represents the height of the cuboid. Okay, so we are going to find the total surface area. Total surface area includes the area of all the 6 faces. In cuboid we are having 6 faces now. The total surface area includes all the 6 faces, area of all the 6 faces. First we will see one by one. First we are taking the bottom and top. See the sides of the bottom and top. We are having the measures include the length and breadth. It is in the shape of rectangle only now. So it includes the length and breadth. So we have 2 identical faces now, 1 and 2. So the area of top and bottom will be given as 2 into LB, 2 into length into breadth. Short form of length and breadth we will use here L and B. Okay, now see the next 2 identical faces. Coming for the next 2 identical faces, these 2 faces include, see, this is called as the length and this part is called as the height. To find the area of this face we have to multiply the length and height. Again we are having 2 identical faces for this. So plus 2 into length into height. Now the remaining 2 faces we are having now in these two faces, see, what are the measures we are having to find the area of this face? We are having the breadth and height. We are having the breadth and height. So, two faces are there. So, plus 2 into breadth into height. So, see, the total surface area I told the sum of 6 faces, the sum of area of 6 faces. So, two identical faces are there. So, we are getting the 6 faces. The total of 6 faces is 2 into M plus B plus 2 into L into H plus 2 into B into H. From this is the total surface area formula, but we can shortcut this formula by taking 2 common outside, isn't it? See, for all the terms we are having 2 common. If we take 2 common outside, the remaining will be LB plus L into H plus B into H. So, finally, the total surface area of the cuboid is 2 into length into breadth plus length into height plus breadth into height square units. Whenever you are finding the area, we are multiplying the measures. Okay, so you have to put square units. Yes, now clear the total surface area. So recall that, remember that the total surface area is nothing but the sum of area of all the 6 faces. Okay, so each face, if you see each face, using an example, if you see this, we are multiplying the length and breadth in 2 faces. So we are having 2 into L into B. And if you take the next phase, we are multiplying the length and height. So L into H. And the next phase, we are having breadth and height. So 2 into breadth into height. By simplifying the formula, we are getting 2 into L into B plus L into H plus B into H square unit. This is the total surface area of the cuboid. Now, come to the lateral surface area of the cuboid. What is the lateral surface area of the cuboid? Lateral surface area, in other words, we can say it is a curved surface area. Okay, it includes only this part. Okay, the surrounding part. It will not include the top and bottom of the cuboid. Okay, the lateral surface area will not include the area of the top and bottom of the cuboid. It will include only the other 4 faces. Okay, so see 1, 2, 3, 4. These 4 faces only included in the lateral surface area. These 4 faces, we are having one face as height into length into height. We are having 2 identical faces now. So 2 into L into H. Other 2 faces include, these 2 faces include breadth into height. So plus 2 into B into H. See, only 4 faces. The top and bottom faces of the cuboid is not included in the lateral surface area. Only other 4 faces. So if you calculate the area and simplify the formula, what we can take common? 2 into H. The remaining is L plus B. So the lateral surface area of the cuboid is given by the formula 2 into H into L plus B square units. Okay. Now coming to the volume of the cuboid. Okay. Volume. If you want to say the volume of this box, okay, volume of the box means we will say the capacity of the box. How to calculate the capacity of the box means we have to calculate the base area. We have to calculate the base area and height of the container. Whatever the shape is there, the volume is given by the base area. Okay, the base area and height of the container. Here for the cuboid, what is the shape of the base? The shape of the base is in rectangle. So the base area means it includes the area of the rectangle and height is given by the word H. So simply we can say that the volume is nothing but the base area into height. Here the base area is in the form of rectangle. So we can give it as length into breadth into height. So the volume of the cuboid is given as length into breadth into height cubic units. Because why cubic units? We are multiplying the measure for 3 times. So centimeter, if you are taking centimeter means centimeter into centimeter, centimeter square into centimeter, cubic units will come. So only we are taking the cubic units here. Okay. Now finally the length of the diagonal. The length of the diagonal, we know what is meant by diagonal first. The line which joins the 2 opposite vertices. Vertex is called as the diagonal. Okay. In the cuboid, which line is the longest line which joins the opposite side of the vertices is called as the diagonal of the cuboid. How to frame the diagonal of the cuboid? We have actually, if we cut the cuboid box and if we make a diagonal, We will get a right angle triangle there. We will get a right angle triangle there. It includes the height and this side include the length and breadth. This will include the length plus breadth and this is the diagonal. This is the diagonal. Okay. So the length of the diagonal is given using the Pythagoras theorem. Thus the square of the hypotenuse is equal to the sum of squares of other two sides. Using this concept only, we have created the formula for the length of the diagonal. If we cut and see the diagram, we will get a right angle triangle. Based on that only we are creating. Okay. So the length of the diagonal is given by square root of L square plus B square plus H square, because the length of the diagonal is sum of squares of other two sides. So H square plus other side is L plus B the square, that is L square plus B square. Okay. This is given as L plus B. Okay. Because this includes the measure of length as well as the breadth. Okay. Yes. Now see, we have four formulas here. One is total surface area of the cuboid. The total surface area of the cuboid is 2 into L into B plus L into H plus B into H square units. L is the short form of length, B is the short form of breadth and H is the short form of H. So for formula use this. Okay. And the lateral surface area is 2H into L plus B square units. And the length of the diagonal is given as L square root of L square plus B square plus H square. And the volume of the cuboid is given it as area of the base into height. That is here for the cuboid, length into breadth into height cubic units. So based on these formulas, we are going to solve the problems of cuboid now. Now we are going to solve example 1. Okay, based on the total surface area and lateral surface area of the cuboid. Okay, so you have to learn the formula first. If you are learn the formula, then only it is easy to solve the problem. Okay, so be thorough with the formulas before solving the problem. Yes. Now find the total surface area and the lateral surface area of the cuboid with the length 10 cm, breadth 8 cm and height is equal to 5 cm. It is a direct question. Okay, they gave the length, breadth and height of the cuboid clearly. We need to find the total surface area and lateral surface area just by applying the formula. First, total surface area. We will go with the total surface area. Total surface area. Before that, what are the given things in the question? What is given here? Length. Length is equal to, so write the given first. Length is equal to 10 cm and breadth is equal to 8 cm and height is equal to 5 cm. Okay, write the given clearly first, then go for the formula of the total surface area. What is the formula for total surface area? 2 into L into B plus L into H plus B into H square units. So see, your length, we are taking the notation scale, breadth as B and height as H. Okay, so we are using the short form in the formula. So what is the total surface area formula? 2 into length into breadth plus length into height plus breadth into height square units. So just substitute the values here. What are the values we are having? Length into breadth. What is length? 10 into H plus length into height. What is length? 10 into 5 plus of breadth into height. What is the breadth we are having? 5 into H. Breadth into height. Now 2 times of 10 into 18. Sorry, 10 into H, 80. 10 into 5, 15 plus 5 is 40. Add all those things. What is the answer we are getting? 2 into 80 plus 50, 130. 130 plus 40, 170. 170. Now 2 into 170 will give you 0. Sums of 14, 4 into 1, 340 centimeter square. Each measure we are given is in the form of centimeter. So if you multiply, you will get as centimeter square. So the total surface area of the cuboid is 340 centimeter square. Also we have to find the lateral surface area, isn't it? So let's recall the formula for lateral surface area. Lateral surface area. into L plus B square units. So substitute the values of length, breadth and height here. 2, keep it as constant. What is the height in the given? 5. So 2 into 5. Instead of bracket, we can use the multiplication symbol also. Okay. Into L plus B. What is the length and breadth? The length is 10 and the breadth is 8. So 10 plus 8. First we multiply this. 5 is 10. And if we add this, we will be getting 10 plus 8 is 18. So totally we are having 180 centimeter square. So see, very simple problem, no? If you know the formulas clearly, it is a direct problem. And if the question they give length, breadth and height means just by using the formula, substituting the appropriate value, we can find by our mathematical operations. Okay. So we have to be enough strong in the multiplication and addition. So we got the value of total surface area as well as the lateral surface area. Now see the second example. This is also a direct example to find the length of the diagonal of the hall. See the question. Find the length of the diagonal of a hall 10 meter long, 5 meter wide and 10 meter high. There is a hall. Okay, they are telling about a hall. Okay, which is 10 meter long. Long represents here is the length and 5 meter wide. Wide represents here the breadth. And the height means it is the height of the hall. Okay, so the hall is represented in the cuboid shape. Okay, indirectly they are telling to us to find the length of the diagonal of the cuboid. Okay, here, so first write the given. Okay, so what are the given things here? Length. Instead of long, we can take it as length is equal to 10 meter and breadth. Breadth is equal to 5 meter. And height is equal to 10 meter. Height is equal to 10 meter. These are the given things here. We have to find the length of the diagonal. So how to find the length of the diagonal? Length of the diagonal. Length of the diagonal. What is the formula? Recall once. What is the formula for length of the diagonal? So length of the diagonal is equal to square root of L square plus B square plus H square. This is square root of L square plus B square plus H square. How to substitute the values and get the answer? So what is L square? What is the length here? 10. So 10 square plus height is 5. So 5 square plus again what is the breadth is 5 and again the height is 10. So which is square. So 10 square means we have to multiply 10 for 2. 10 into 10 it is 100. 10 tens are 100 plus 5 5s are 25 plus 10 tens are 100. Now add totally what is the value we are getting? 100 plus 100 200. So 225 which is equal to 15. What is the square root of 225? Which is equal to 15. So 15 meter. The length of the diagonal is 15 meter. Here we are finding the length only, so it will come under units. So the length of the diagonal is 15 meter. Okay. So see here for 225, you may use the prime factorization method to find the square root. Okay. See, I put the value directly there 15, but using the prime factorization method. Okay. Shall we start with 3? Because 2 is not possible here. Start with 3. 7 3s are 21, remainder 1 and 5 3s are 15. Now, is it possible to divide by 3 here? Check once. 3. 2 3s are 6, remainder 1. So 15. Again 5 3s are 15. Yes. Now 25 is not possible to divide by 3. So go for the next prime number 5. 5 5. So 5 1. So the square root of 225 is equal to 3 square into 5 square. We are having 3 for 2 times here and 5 for 2 times. So 3 square into 5 square. That is 3 into 5 the whole square. So square root of 225 is equal to 15 square. So if you cancel square and square root, they are reciprocal function, the value is 15. So whatever the your number getting in the square root, either you can use the long division method or prime factorization method. Okay. So here I use the prime factorization method and got the value of square root of 225 as 15. Okay. So next we will solve the next exercise problem. Now starting with exercise problem. In exercise 16.2, first problem. Okay. See the question. Find the width of the hall with the diagonal 26 meter. With the length of the diagonal 26 meter and length of the hall 21 meter and height 15 meter. Okay. Here the question is not directly given here. They gave the length of the diagonal in the question, also the length and height of the hall. We have to find, what we have to find? The width of the hall. In other words, we have to find the breadth of the hall. Okay. So first write the given. So what are the things given here? Length of the diagonal. What is given? Length of the diagonal. What is the length of the diagonal? Which is equal to 26 meter. And what are the things, other things given here? Length of the hall. Length is equal to 21 meter and height is equal to 15 meter. These are the things given in the question. Okay. Now we have to find the width of the hall. In previous problem, they gave the question length, height and width. We found the length of the diagonal. Here the length of the diagonal is mentioned in the question. We have to find the unknown value width. Okay. So how to find it? We know that the length of the diagonal formula. Okay. What is the formula? Square root of L square plus B square plus H square. Okay. So the length of the diagonal is equal to L square, B square plus L square. But here in this question the length of the diagonal is mentioned. So we can take it as 26. Okay. Now I want to remove the square root. Then only we can identify the value of breadth here. Okay. Square moves that side, or to remove square, what we have to do? We have to square on both the sides. If I square on both the sides, L square, B square plus H square is equal to 26 the whole square. So that the square root is removed. Now substitute the value of what is given in the question. What is the length? 21. So we can take this 21 the whole square. Breadth, that is the width, we don't know. So keep as it is. And what is the height we are having? 15. So 15 the whole square is equal to 26 square. What is 26 square? We have to multiply 26 into 26. 26 into 26, 676. Now find the value of this. What is 21 square? 21 into 21 it is 441 plus B square and 15 square. In previous problem only I solved for the square root of 225 is 15. So 225 is equal to 676. Now get the values. If we want to find the by B square, we have to add these two values and change to the next side of the equation. So 441 plus 225. If we add, we will get the value as 666. Just the normal addition. If we add 441 and 225, it is 666 equal to 676. Now I want B square. What we have to do? We are familiar with this, no? Unknown to find the unknown value. We solve the algebraic equations. Now B square is equal to 676 minus 666. Because in plus here goes under that, it comes under minus. That is B square. If I subtract this, the value is 10. But we want the value of B. So B is equal to square root of 10. Here 10 cannot be simplified. Okay. So keep as it is as square root of 10. So B is equal to, therefore the width of the hall is equal to square root of 10 meter. Okay. If you want to find the square root, it is also good. We can use the long division method and we can find the square root for the 10. Okay. So now see here, the length of the diagonal is given, length and height is given. We have to find the width. First write the formula and substitute the values. See, B is inside the square root. Okay. The unknown value inside the square root cannot be found. So to remove the square root, we are taking the square on both the sides. If we square, the formula will change as L square plus B square plus H square is equal to square of the length of the diagonal. That is here 26 the whole square. After that, by substituting the length value and height value, just making the squares and adding the values. We want to find only the B square. The unknown value only given is here B square. So keep B square to one side of the equation and take the numbers to the next side of the equation. We got 10. Here 10 is not a square number. Okay, so square root of 10 cannot be solved. Okay, we can give the answer in the form of decimal. Okay, but now it's enough to find out here B is equal to square root of 10 meter. Okay, so any question given like this is little twist. Okay, the diagonal is given, area is given. To find the measures of length, breadth, height, just substitute the given values in the formula and start solving in your own. Okay, by using whatever the mathematical rules, then we will get the unknown value. Okay, now we will solve the second problem. Now see the second problem. Actually this is also similar to the first problem only. But why I am solving is here we are having the square root so that you can be clear with how to solve the numbers inside the square root. Okay. Here the similar problem only, but here they gave the length of the diagonal, they gave the length and breadth. We have to find the height. In last problem we find out the breadth. Here the same model only, but we have to find out the height of the cuboid. Okay. So what are the things given here? Given they gave the diagonal length. Diagonal length is equal to, what is the length of this diagonal? 4√7 centimeter. Length of the diagonal is 4√7 centimeter. And length, long is taken as length is equal to 6√2 centimeter. And wide is taken as breadth. And you can use the word wide itself. Okay, wide is equal to 4√2 centimeter. Okay, now we have an idea how to solve this. Yes. So first we are going to find the take the diagonal formula. What is the diagonal formula? Length of the diagonal formula: L square plus h square plus b square, or L square plus b square plus h square. Okay, that is the diagonal formula units. So now guess what we are going to do? Yes, we are going to substitute the value of diagonal first. What is the length of the diagonal? 4√7. So 4√7 centimeter is equal to square root of, substitute the other values, length is 6√2. So we are having the square, L square. So the square comes for both the number as whole square. Plus h square, what we have to find. So keep as it is. And the breadth wide is given as 4√2 the whole square. 4√2 the whole square. See, just checking the diagonal formula and we are substituting the given value in the formula. As I told before, to remove the square root, we have to take square on both the sides. So we are squaring on both the sides. Squaring on both the sides. So squaring on both the sides. So if we square on both the sides, 4√7 the whole square is equal to square root of 6√2 whole square. We will do the square here later, plus 4√2 the whole square. Okay, square on both the sides is just we will take square on both the sides. Here square and square root will get cancelled. Okay, this square is common for both 4 as well as √7. This square is common for both. We know the rule. Okay, A, B. The whole square is can be considered as A square into B square. The same rule applicable here. The square is common for both 4 as well as √7. So 4, if I take the square separately, 4 4s are 16. For √7, if we take the square and square root will get cancelled. Okay. As well as here also we cancel the square and square root because square root value is 1/2. So 1/2 and 2 are reciprocal function now, so they are getting cancelled. Okay, that's why we are telling that square and square root will get cancelled. Now, this square is common for both 6 and √2. So 6 will become 6 6 are 36 and √2 as √2 the whole square. Plus, I don't know the value of h square, so we will keep it at the last. Now 4 4s are 16, √2 whole square plus h square. See, 2 2s are 4 4s are 16 and 2. Now see, the root functions will get cancelled with the square. So yes, we cancel. What are the remaining we are having? 16 into 7. We are having 16 into 7 equal to 36 into 2 equal to 36 into 2 plus 16 into 2. 16 into 2 plus h square. We want to find the h square. Before that we have to multiply the numbers now. What is 16 into 7? 16 into 7 is 112. 112 is equal to 36 into 2. What is 36 into 2? 72. plus 16 into 2. 16 into 2 is 32 plus h square. That's what we have to find. Now 112 is equal to what is 32 plus 32, which is 104 plus h square. We have to find the value of h square. We want to find the value of h square. How to find h square? Just replace 104 to the next side of the equation, so we can solve the value of h square. So we can rewrite this equation as h square is equal to 112 minus 104. What is 112 minus 104? H square is equal to 8. We are getting the value of h square is equal to 8. Okay. But we want to find the value of h here. Okay. So how to find the value of h? See here. We have to find the value of h. We got that h square is equal to 8. So h is equal to, we can write it as h is equal to square root of 8. Square root of 8. In previous problem we got square root of 10. I told for 10 we can't find the exact square number because it is not a perfect square. We can get the decimal value. But here 8 is also not a perfect square. But we can simplify 8. Okay, we can simplify the square root of 8. How? H is equal to, we can write it as 4 into 2. Okay, because 8 has one square number inside. The maximum square number of 8 we are having is 4 2s are 8. 4 is a square number. So if I take 4 outside of the square, we will get 2 root 2. 2 root 2. Therefore, the height of this given cuboid is 2 root 2 meter. We can conclude the answer as 2 root 2 meter. So here 8 is, why the 10 cannot be simplified? That means 10 cannot be written in the form of any square number. 10 can be written as 1 into 10 and 5 into 2. These are the factors for 10. Here we can't find any square number. But 8 we have the factor of 4, which is a square number. So it is possible to simplify the square root of 8 as 4 into 2. 4 is a square number. If I take the square root of 4, we can take it as 2. So 2 root 2 meter. Therefore, the height of the given box is 2 root 2 meter. Okay. See, whenever you are having the square value, square and square root will get cancelled. And inside the bracket, if you are having a, b, the form of whole square is, the square is common for both a and b. So you have to apply the square for a as well as b. See here, 6 6 are 36. Here we are having square root, so it will get cancelled. Okay. And important thing, any square root number, if it is not a perfect square number, means if it is possible to simplify the square root number, means simplify and give your answer. Okay. So finally we write the height of the box as 2 root 2 meter. See the next question. The volume of a cuboid is 72 cubic units. If its breadth is 4.5 and height 2 cm, find its length. The problem is based on the volume of the cuboid. What is the volume of the cuboid formula? Area of the base into height. Here the area of the base represents the shape of the rectangle. So L into B into H. So it is given as length into breadth into height. Okay. So that is the volume of the cuboid. Here the length is given as the length we have to find. The breadth and height is given. Also the volume is given. Okay. We have to find the unknown value length here. Just by substituting in the formula. Okay, how we find the value of height and breadth in the diagonal, using the diagonal, the same way we have to use the formula, substitute inside the formula and find the unknown value. Okay, what are the things given here? Length. First write the given length. Okay, we have to find, isn't it? Yes. What are the next things given here? Volume. Volume is equal to 72 and breadth is equal to 4.5. Breadth is equal to 4.5. See? And height. Height is equal to 2 cm. So the length what we have to find here. First write the formula of cuboid. Volume of cuboid is equal to length into breadth into height cubic units. Okay, whenever you are finding the volume, you should use the cubic units. Because we are multiplying the measure for 3 times. Okay, so what is the length? We don't know. So length keep as it is. So make length as it is. Length into. What is the value of breadth given here? 4.5 and the height is 2. And the volume of the cuboid is given in the question as 72. So So see, except the length, we got all of the values in the formula. So 72 is equal to L into, what is 4.5 into 2? It is 9.0. We can take the value as standard value as 9. Okay. So we want to find the value of L. Keep L, make 9 to the next side of the equation. 9 here is under which operation here? Multiplication. So it comes to the next side of the equation, comes under division. So we can rewrite the equation as L is equal to 72 by 9. Okay. So if I simplify by 9, L is equal to 1 minus 9 and 8 times are 72. So L is equal to 8. Okay. What is the measure given here? It is given in the form of centimeter. This is cubic units. That is cubic centimeter we can write, and this is centimeter. As well as this is also centimeter. So the length of the cuboid is 8 centimeter. See, it is a simple problem. Volume is given. Substitute all other values except length. Just rearrange the equation for L. We get the value of length as 8 centimeter. Find the new volume of a cuboid whose length is increased 4 times, breadth is reduced to 1/4, and the height is left unchanged. Actually, that is a cuboid which has a specific volume. Okay, if some changes in its length, breadth and height, but height is here remains unchanged. If some changes in their length and breadth, what will be the new volume? That's the question here. Okay, first we will fix the value for the old volume of the cuboid. Okay, so we can take letter L, B and H be the length, comma, B is for breadth, and height of the older cuboid respectively. So see, we are taking length L, B and H be the length, breadth and height of the old cuboid respectively. So what will be the volume of the old cuboid? So volume of old cuboid. Because if we know only, we can say what is the difference between the volume of the old cuboid and new cuboid. So we are fixing the volume of the old cuboid as we are having length into breadth now. So length into breadth into height. This is equal to L, B, H cubic units. Cubic units. We are getting it as length into breadth into height cubic units. Now the volume of new cuboid. Volume of new cuboid we are going to find with the changes given in the question. What is given? The length is increased 4 times. So we can take the length as 4 into L. Okay. So into breadth is reduced by 1/4. That is breadth is B by 4. The breadth is reduced by 1/4 is B into 1/4. That is directly taken as B by 4. And the height remains unchanged. So this is the new length, breadth and height given for the new cuboid. So multiply this 4 and 4 will get cancelled. So the remaining what we are having is length into breadth into height cubic units. Cubic units, which is same as the old cuboid. So if we do some changes, the given changes in the cuboid, we will get the volume as same. The new volume as same as the old cuboid. Okay. So if we take this question some more with some technical with some changes. Okay, if they gave instead of 4 times they gave the length as 3 times this 3 into L. If the breadth is 3/4 of that, means you have to take 3/4 they gave us, we have to take it as 3B by 4. So according to the given condition in the question, we have to take the value of change the value of length, breadth and height, and we can find the volume of the new cuboid. Okay, yes. Now we'll go for the next problem. Yes, now see this problem children. It is a different problem. See here, a cuboidal juice pattern has a square base of side. Okay, there is a juice bottle which has a square base. Okay, it is a cuboid only, but the base of the base is in the form of square. Okay, if with the height 20 centimeter, if 30 guests are to be served 200 ml of juice each, how many each juice will be required. Okay. So the question here, what it tells, actually we are having a juice bottle, okay, juice carton, which has the base as square of side 5 cm and height 20 cm. Its base side is 5 cm and the height of the bottle is 20 cm. There are 30 persons who have to be served with 200 ml of juice. For each person we have to serve 200 ml. That means how many juice cartons we are required? That is the question here. Okay. First, how to find it? First we must know one juice carton will have how much capacity. Okay. Capacity means volume. What is the volume of one juice carton? Okay. So how many people can be served using one juice carton? Okay. Based on that volume only we can tell the requirement. Okay. So how many juice cartons are required? Okay. First we will find the volume of one juice carton. Okay. Now for cuboidal juice carton, base side is given as 5 cm and height is given as 20 cm. What is that? First we have to know the volume. What is the capacity or how many ml of juice contained in one juice carton. So we are going to find volume of one juice carton. So it is in the cuboidal shape now. So we can take it as area of base into height. We can make it as length into breadth into height also, but here the area of the base is specifically given as it in the form of square. So what is the area of the square? A square, side into side. So we are having here 5. So we can take it as area of the base is given here as 5. So we can take it as 5 square into height is 20. What is 5 square? 5 5s are 25. 25 into 20, which is equal to 500. 25 to 2 is 50 and 0, so 500. What it is given as centimeter. 500 centimeter cube, because we are finding the volume. Okay, but it is in centimeter cube. But we want it to find the value of ml. How much ml does one carton contains? So how to change it as ml? Okay, we know that 1 centimeter cube is equal to 1 ml. 1 centimeter cube is equal to 1 ml. So if you change 500 centimeter cube, how much ml you will get? Yes, 500 ml. So therefore 500 centimeter cube is equal to 500 ml. 500 centimeter cube is equal to 500 ml. So before solving the problems, we have to come up with the measures, conversion of measures also from centimeter to meter, likewise liter to milliliter or centimeter to milliliter. Like that we have to learn the conversion also. Now okay, 500 centimeter, so we got 500 ml. So the capacity of one juice carton with the square base is what it is? 500 ml. Okay. Now okay, but here the question is, for 30 persons we have to serve 200 ml. First we have to know how much capacity we need. So we are going to find total volume or total capacity. That is 30%. We are going to split 200 ml. So what is 30 into 200? Which is 6000 ml. So in total we need 6000 ml of juice. But one bottle contains only 500 ml of juice. So how to find how much juice carton is required? Yes. Now number of juice cartons required is equal to 6000 by 500. So total requirement by the volume of one carton. Okay. So if I divide this 60 by 5. What is 60 by 5? It is 12. So how many juice cartons they require? 12. To serve the 30 people we need 12 juice curtains. See here how many they are asking. So it is 12. The requirement is 12. Okay. So like this, today we have solved the problems. Somewhat we solved the direct problems of cuboid. Somewhat the real life problems we have solved. Okay. So what you have to do in your home, just take the cuboid shape. Analyze the cuboid shape first. For example, I showed the first aid box. In our home, you will have your pencil box, even your book or any other container you will have in the cuboid shape. So first analyze the shape of the cuboid. Okay, how many faces it has? What are the identical faces? Which size has the length and breadth? Okay, so do the clarity work yourself. Okay, so see the cuboid first, analyze and guess the formula of total surface area and lateral surface area. If you use the cuboid shape and if you fix the formula in your mind, the formula will never forget from your mind. Okay, so be thorough with the formulas of total surface area, lateral surface area, volume and length of the diagonal of the cuboid and solve the problem. Based on this problem, you will get your assignment problem also, children. So try to solve your assignment problem based on the same manner and post in the group. Okay, thank you, children.